Hello, guys. Good afternoon. Thanks for joining us today. We are going to start in a moment. One more minute, and we are going to begin our today's topic. What's the difference between Arduino and Raspberry Pi? So stay tuned. One more minute before we get into this session. Okay, guys, welcome. Thanks for joining today on our 5th Cytrons webinar series. Today we'll talk about what's the difference between Arduino and Raspberry Pi. It will be me alone today, unfortunately, but let's hope that Ober will be able to join in and be with us to explain on his experience with Arduino and Raspberry Pi. Okay, but without wasting more time, let's go into our first part of this topic. The agenda of today is first, before we even explain about what is Arduino and Raspberry Pi, we're going to talk about what is microcontroller and what is microprocessor. The comparison between microcontroller and microprocessor. If you are a student here, you have probably never came across a microprocessor. You probably came across microcontroller, but what I can tell you is that these both exist around us, even on your hand right now, the things that you're using right now, and the appliances available around you. So put it this way, we are gonna compare between a vacuum cleaner and a laptop. All right, so we're gonna do that later, and after that session, I'm gonna talk about the difference between Arduino and Raspberry Pi, and last but not least, we are gonna talk about which is better. Okay, is there a comparison between them? Okay, and then we are gonna close the webinar with some summary, and if we have more time, we're gonna hear and answer your questions in the comment section. So if you are here for the first time, please drop your comment, drop your questions in the comment section. If you're on YouTube, drop your comment on the right side panel. If you're in the Facebook, you're watching this from Facebook, drop your comment as well. I will try my best to answer your questions in between of our session. Okay, let's move on. So first, take a guess. Which is microcontroller and which is microprocessor? Take a guess. Take a rough guess. I have one microprocessor here and one microcontroller here. If you look closely, you will be able to tell which is which. I actually included some hints in the photo. But if you are not able to tell the difference between these both, well, because basically they look almost similar to one another, what about this photo instead? Now, do you know which is a microprocessor and which is a microcontroller? Okay, I have some answers over here. Yep, you are right. So on the left side, we have CPU, processor, and then wait. Okay, the answer is actually on the left side microprocessor and on the right side microcontroller. Okay, right side microcontroller. Yes, we have some who got the answer right. Right side microcontroller and the left side microprocessor. Microprocessor is actually used in our CPUs, our laptops, our PCs. And microcontrollers are actually used in devices with specific application, specific functions. Okay, I'm going to tell you more on what are these applications next. And then later on, I will explain a bit on the internal structure of these devices. So get right down to it. Before we even talk about the technical side, we talk about the application of microprocessor and microcontroller. A microprocessor is designed for unpredefined tasks, meaning you don't give a specific task. Oh, let me stop this. For microprocessor, you don't, okay, when you use a microprocessor, you don't specify the task that you want it to be used for. That's why it's meant for more than just a specific task. Things like web browsing, photo editing, or even mathematical calculations, creating documents and gaming, all of this can be done in a laptop or a CPU. And in the laptop or a CPU, we have a microprocessor processing all these different tasks. When you are using a laptop, you don't just use for a specific reason. You don't buy a laptop to create just documents. You buy a laptop to do more than that. Web browsing, photo editing, gaming, and all of this requires the use of a microprocessor. As compared to microcontroller, it is designed to perform specific tasks. And here are two examples, a vacuum cleaner and a camera, a digital camera. This requires microcontroller, means that it controls specific individual components in these devices. It still works as a system where it controls the arm of a robot or the eyes of a sensor or the ultrasonic of a vehicle. So, but it comes with a specific task. Okay. I'm gonna lay out more detail on what you can actually do with a microcontroller and a microprocessor later. But you get the idea. Microcontroller, you give him a specific input and it gives you a specific output. Okay, so this is how you explain it to a student or someone who are new to what is microprocessor and microcontroller. And then later on, we will dive into the more complex stuff, which is the internal structure of a microprocessor and a microcontroller. A microprocessor, of course, contains a CPU. It is the CPU. With the CPU, it works with the RAM, the ROM, the input and output ports, and timers, and also the serial interfaces like USB or Ethernet. A microprocessor works with all of these different components. And when you look at the microcontroller side, the microcontroller also have the same thing, ROM, RAM, input, output ports, and also timer and serial interfaces. But the big question here is, what are the difference between these two guys, like these two components, microprocessor and the microcontroller? The microcontroller actually have everything all packed in a single chip, in single IC, integrated circuit. So they consist of CPU, RAM, ROM, pins to control the input and output, timers, and the serial interfaces for everything in one. As for the microprocessor, if you have a desktop at home, you open up the desktop, you will be able to see the microprocessor is sitting at the center of the motherboard. And then you have your external RAM slot in. You have your serial interfaces. You have your timers. You have everything else externally. It's not all integrated into a single system. All right. So this is the architecture. You don't have to dive in deeper on what it means, but of course you need to know what is RAM, what is ROM, what is I/O ports, timers, serial interfaces. But again, one have everything integrated together and one doesn't. And we are going to compare the specs for Arduino and Raspberry Pi later on what's the difference between these two things and why having everything in one is not as good as everything in separate form. Right? We will look at the specs on that. Right. So again, those who just joined, please drop your questions in the comment section and I'll try my best to answer your question. And if we have not enough time, I'll bring your questions later on. I will comment in the comment section as well to answer your questions. But hey guys, you are here to learn, and I hope you drop your questions in the comment section. I wish that you learned something here at the end of today. All right, so back to the serious question here. Arduino versus Raspberry Pi. What are the difference between these two, Arduino and Raspberry Pi? First, Arduino is a microcontroller. It works on a specific way. You give him a specific input, it gives you a specific output. A Raspberry Pi, on the other hand, is a microprocessor. Okay, you give him a specific input, it still gives you a specific output, but it works differently, and it works like a computer. A microcontroller, an Arduino, is not a computer. Okay, but it can be the heart of a robot, and a Raspberry Pi, it can be a computer. I mean, it can also be a heart of a robot. All right, I hope you don't get confused with this application comparison, but let's dive into the specs and later on the application, so you'll be able to understand what and which should I use when I want to build a project. So for Arduino, it is a microcontroller. The microcontroller is Atmega 328 P8-bit, and Raspberry Pi, it's a microprocessor with a processor, all right, Cortex A72 64-bit. The clock speed for Arduino is 60 megahertz, and the clock speed for Raspberry Pi is way higher than that, 1.5 gigahertz. Right now, I'm just comparing Arduino and Raspberry Pi with the specs that they both share. And of course, the spec sheet is longer than what we have right here. But the clock speed, as you can see on a microcontroller, it's so much lower as compared to a Raspberry Pi clock speed. This is due to the processors behind the controller and the processor is different. They are designed to perform different functions. All right, and again, everything, RAM, ROM, flash memory, the interfaces are all integrated into the controller itself, one controller itself. As for the Raspberry Pi, the microprocessor sits at the center, the RAM sits at the other end, the GPU sits at the other side. Everything sits at different places. Okay, know the difference. Microprocessor sits there, but the RAM is somewhere else, the ROM is somewhere else, the peripheral interfaces are somewhere else. As for the Arduino microcontroller, it sits there, everything is inside. That's why the RAM, the ROM, the clock speed is all slower. Okay, so this is just a simple comparison. Actually, I'm not going to go into detail on what's inside the controller and what's inside the microprocessor. Basically, it's all just transistors performing different functions. So when you put in input, it gives you different output. But I'm not going to go in deeper. I hope you get the point. Okay, so next question is, which is better? Right, this is the biggest question. If you are a student, again, you will probably ask this at least once in a lifetime, or even if you are a teacher or an educator, you probably ask this when you started your making journey. When you decided to build something, you will first ask, which controller should I use? Which board should I use? Should I use a Raspberry Pi or should I use an Arduino? This question always comes up. Okay, but you need to know that a Raspberry Pi may not do what an Arduino can do, and an Arduino may not be able to do what a Raspberry Pi can do. It's like comparing an apple with an orange. It's two different things. Okay? They both perform differently. So first, ask yourself, what project am I going to build? What do you want to build? If you want to build a robot, think about which board you should use. Okay, of course, there are so many types of Arduino and there are so many types of Raspberry Pi. But let's just compare between controller, microcontroller, and a microprocessor. Which do I really need? Why am I saying this is because if you choose the wrong option, it will cost you more. Okay, and it will cost you a lot of unnecessary costs as well. A microcontroller is way much cheaper than a microprocessor. It's like saying I want to buy a mini fan, a handheld fan, and a laptop. Right? A fan have a specific function. It blows air to my face, but I don't buy a laptop with a fan integrated into it just to do that. So it's two different things. You can't compare a fan with a laptop. Okay, so ask yourself this question: what project am I going to build? Next, here are 3 simple questions that you should ask after you identify what project you want to build. Do I need to process videos and pictures? Do I need graphic interfaces in my project? Do I need to process complex algorithms? Do I need to do all this? Okay, do I need to see data on the screen? Do I need to edit photos or videos? Do I need to do 3D modeling? Or do I need to process a lot of data? If my answer is yes, then the answer is a Raspberry Pi that you need, because a Raspberry Pi works like a computer, like a CPU. Okay, it requires a mouse, a monitor, and you can have speakers, and you can have everything that you need for a desktop to function, right? Monitor, mouse, keyboard. And of course, with a monitor, you have your screen and you'll be able to see your data. So with that screen, that graphic interfaces, you are able to compress, edit your pictures, edit your videos, or even perform image processing, or things that requires a graphic interfaces. Where else for an Arduino? No, you can't process videos and pictures. Basically, you can, but in a very small size. Okay, you can process it in a very low level binary form for images. You still can do it, but there will be no graphic interfaces for you other than LCD screens, and then it won't be able to process complex algorithm. All right, so no. If your answer is no for this, you will probably be able to. You probably be able to decide which microcontroller or microprocessor you should use. Okay, now for our special guest, Mr. Ober, he's here right now. I'm gonna invite him here. Okay, let me pull him here. Hi, Ober.
Hey, sorry.
It's okay. Come. So yeah, do share
Thanks
us your
for.
experience on microcontroller and microprocessor. No problem. No problem. Yeah, we are here.
Where are we just now?
We are so we talked about the internal structure of microprocessor and microcontroller, the application, simple application, but we just touched this lah, the questions that we asked, which one is better. Maybe you can share a bit on your experience on what an Arduino does as compared to a Raspberry Pi, like
Oh, okay.
what you can do with it.
I think just now, okay, we gone through the slide in the front already.
Yes.
So I think you cover those I/O, right? For example,
Yeah. Let's.
the purpose.
Yes. This one.
Okay. Yeah. Okay.
Okay. So.
So we go back to here.
Yeah.
Yeah. So the question you answer already. This one.
Yes, we go through the questions, and then right now it's more on opinions on which one is better, and basically just answering which is better.
I don't
Arduino
think
and
there's better one. So you going back to what's the purpose, right? What's the
yeah.
purpose? And normally for student nowadays, they will have a project title. So I don't think they have problem choosing one because normally in the title they have that requirement in the project already. So
Yeah, I think
yeah, okay. So but for me, those that need to use, for example, Raspberry Pi, is more difficult to get started. One reason is it need OS, right? processor will need the OS.
Yeah.
Then microcontroller, you can use it using another computer to write program, right? But
Yeah.
for example, Raspberry Pi, you need to write program on the OS itself, on
Yeah.
the OS itself. So to get started with Raspberry Pi is more complex if we are talking to on how to get started lah. Yeah.
Yeah. Okay, let's just look at the price lah, the price comparison. Like why the
Mm.
microcontroller is so cheap as compared to a microprocessor? Is there like a it's like a why?
I think volume lah. One of it is volume, and of course
Mm,
the internal architecture also is more complex. We know, for example, IP, right? Those architecture, processor architecture for processor is much more complex and much more expensive, right? Then microcontroller is because of volume. Uh, Almost every electronic component have a microcontroller. Almost
mm,
so the volume is very very high compared to a computer lah. So one of the reason why phone is so cheap now compared to, let's say, 10 years ago, again, volume.
volume, volume.
Volume.
Yeah.
Volume.
Okay. Okay. I have one final question. Then we continue to look at the crowd's question lah. All right. Because we also don't have much
Peter is
time.
also here.
Peter is also over here. A lot of people here already. So the next question that I want to ask is because IoT is a very big topic, people talk about IoT, and the way I see it is Arduino also can do IoT, Raspberry Pi also can do IoT. Like, but which is better if to enter an
Ah,
IoT project? I think this is one big question from a lot of students also.
hmm. uh, I think when we talk about IoT, what you want to do with the IoT lah? As you say, it's very big. For example, I just want to log data, temperature, humidity, whether there's person or not, whether the door is open or not, when is the door open. That one, what we call is just basic sensor node lah, right? So that is the end of the IoT, is the device. So that part you should use microcontroller lah. Don't use the Raspberry Pi just to add a sensor, add a temperature sensor, humidity sensor, maybe a PIR sensor to detect whether there's person or not. Then that as a node is kind of waste because the microcontroller can do it. So of course Raspberry Pi also can do it. I'm not saying Raspberry Pi cannot do it, but Raspberry Pi is kind of waste if you use a Raspberry Pi to do that. Right. Then Raspberry Pi itself, you can do a server or a home IoT server. A lot of smart home use Raspberry Pi to do it as a server. So that Raspberry Pi will do a high level kind of program. For example, the node send the temperature high already. Then the Raspberry Pi will process that signal or process that data to control, let's say, aircon or fan, things like that. So
Yeah.
they play different role in IoT.
Yeah, I think this is very crucial because
Yeah,
if
yeah.
you say like, oh, I really want to build a project, I want to build IoT project, and then it come down to Arduino and Raspberry Pi. If you pick the wrong board, it may cost you more, but you still can
Wow.
do it. Yeah,
Yeah,
you
you
still
can
can do
still
it,
do
right?
it.
You still can do it.
Yeah, yeah.
It costs you
But I
more.
think student project will most likely do the sensor node lah. For example, they log data, then log to a cloud, then display the data.
Yeah,
But if you want to go further, then Raspberry Pi can actually do a very big project lah. But
yeah.
not node lah. Definitely not node. Don't use a Raspberry Pi to do a node lah. Yeah.
Okay, come. Let's take a look at some of the questions here.
Sure, sure.
Okay.
Sorry
All right.
guys, just now I'm late.
Okay, this one is from Sam. So he asked,
Liu.
what's the best way to learn coding for Raspberry Pi?
Oh,
Yeah,
start
this is one
start
of
now, lor.
the
The best way is to start now.
now
Yeah.
this is one of the also one of the biggest confusion out there lah. When people learn about Arduino, they know, okay, Arduino, I use C to learn, I use Arduino IDE to learn Arduino. But when it comes to Raspberry Pi, there's actually no fixed language.
Yeah, no fixed language.
Okay, there's no
Yeah.
fixed language to it. Okay, but a lot of people still prefer Python.
Yep.
Um, all right, so
You,
there's
you
actually
know
no
why
way.
why why the Pi is why Raspberry Pi? Actually, the Pi refer to Python, not the Pi
Right?
3.145 or something like that. No, it's actually the Python. Uh, it have nothing to do with the the cycle
Pi.
Pi. No, it's actually from Python because Python is actually the official programming language for Raspberry Pi. But
Mm,
because Raspberry Pi is a computer with OS there, you can actually install whatever programming language that support the OS or the OS support. So JavaScript can be used, C++, C, Python. What else? What else? A lot more
a
other
lot lah.
programming language.
Yeah.
Even the MicroPython, CircuitPython, then
Oh.
Arduino IDE. Actually, Arduino IDE is Arduino, but they modify the programming language. It becomes C, C++. Then they
Mm,
have their own structure.
mm,
So if you like to call that a programming language, also can. It can also being used on Raspberry Pi uh,
mm.
as a programming language. So
Yeah.
uh,
Yeah.
use Python.
Yeah. Actually, yeah. So another question: can you share examples of uses of microprocessor? I think basically what you just mentioned lah. There are so many programming language out there that you can
Mm.
actually learn using a Raspberry Pi. It's like a PC, right?
Yep, yep,
And
yep.
especially for students these days, lah, right? We need a laptop, we need a PC to learn, right? To
Yep,
even
yep, yep.
attend Google Meet or even attend your online classes.
Actually, if
So
you look at one article, I think they just released it last week. The
mhm,
CEO of Raspberry Pi, Eben, actually last year since the UK also locked down, I think the whole wide world is locked down. So a lot of them need to use computer, and Raspberry Pi come into the picture, especially Pi 4 and also 400. So they use it for conference call, even not only for student, for actual engineer to work. So they might use their computer as daily work, but they also use Raspberry Pi for other purpose. And Raspberry Pi is powerful enough for conference call just now. And one of the things that even highlight is actually Chromium. If you still remember last year or early of this year, we tried to do a Google Meet with Raspberry Pi 400 and also Raspberry Pi 4B. And we have problem on Google Meet to share screen.
mm,
They actually update that. So even actually highlight that. So now Chromium can do conference call. So it's a
can
big
share
thing.
screen also lah.
Yeah, I can share screen. So
Yeah,
it become for us as student, we don't need to share screen. But
yeah,
as educator, it's very important to share screen. Else is talking only,
mm,
face to face talking only. So they need to have show the content. So that is very big update for them. So that's
yeah,
why he highlight it.
yeah.
Yep.
So which like so many, okay lah, we focus more on the microprocessor now lah, about Raspberry Pi. Out of so many Pis, which is the best for students? Like you would recommend
I
Pi
think
4 is also right. Pi 4.
Pi 4 Pi 4. Pi 4 you take 2G the cheapest one, because
Mm,
2 GB for most of the project I'm not talking about all project because we
mm,
also don't know what kind of project you want to do. 2 GB is more than sufficient. So if you like to do networking, let's say a simple web server, you can actually do web server, then do a simple security or home IoT things. 2 GB for Raspberry Pi 4B, 2 GB
mm.
RAM is good enough. good enough. Yep.
So the purpose of Pi 400, the keyboard one,
Yeah.
it's supposed to meant for students, so they don't need to buy keyboard and they can just plug into
Student,
their
yeah. It's
PC,
like
to their TV,
home
right?
home learning, things like that.
Mm.
So you need less one things, which is the
Yeah,
keyboard.
keyboard.
One thing less, right? Then
Mm.
everything is on that keyboard already. So you don't need to, I need to plug this, I need to plug that. Can I use a wireless keyboard? Can I use a USB keyboard? Where to plug?
Yeah,
Things like that.
yeah.
So that's one thing to worry, you know.
Mm.
Yeah.
Okay, thanks. Okay, I think we can proceed to our slides.
Okay, can no
Okay.
problem. So
So
summary
yeah,
summary
yeah.
you summarize because most of the slide you talk about it.
So basically, we talk about microcontroller versus microprocessor. Again, when we compare Arduino versus Raspberry Pi, it's like comparing apple and orange, lah. Two different
Yes,
things, lah.
yes, yes,
Right?
two different things.
So we highly recommend that we don't compare it this way. Instead, we ask question which is right for my project. If
Yep,
you can
yep.
answer that, then you know which is suitable for you. If you
If you
don't
cannot
understand,
answer, right, ask us, ask
yeah,
us.
yeah, yeah. So okay, ask us by joining our Telegram group, right?
Yep,
Citron, our role is actually to connect the community, the makers community, and also the 3D printing community. If you have any questions, drop your questions in this Telegram group, and not just people from Citron, but
yep.
every makers around will be able to help you. Okay, so and then next week, okay, I'm just gonna summarize our today's presentation because we don't have much time. But next Wednesday, we are gonna have a microbit classroom live demo, which will be interesting for teachers and students, especially for educators. So we welcome you to join us. Okay, and then last but not least, drop your feedback. If you
Feedback.
want to hear, yeah, if you want to hear more on this kind of topic, let us know what kind of topic you are interested in, and we would like to hear it from you. And of course, we are gonna not gonna end it yet. We are gonna spend another 3 minutes to answer some of the questions
Yep,
here.
yep, yep,
Yeah.
yep.
So feel free to drop more questions.
No
Then we will
problem.
try our best to answer. Okay. Right. Like Peter shared. Okay. To him, both Pi and Arduino have specific projects or
Yes,
specific
yes, yes.
for advantage.
Yeah.
Okay. And then
For
okay,
example,
let's
if you
see.
want to do networking, you better do it with Raspberry Pi. You want to do anything with networking.
Yeah. So my brick, you have a question. Raspberry Pi requires similar power like Arduino or more.
Definitely more. Definitely more. But if you are talking about voltage, actually both of them is using 5 volt.
Yeah.
Oh,
Basically, you can power a Pi with a power bank also.
yep, can. Actually,
But
they did. Some
yeah,
maker did it. Yep.
yeah. It's just that if you run heavy processing, it may be unstable for the power sometimes,
Yep.
right? The ampere need to be enough. Okay, next question. What are the sensors that are unable to connect to Pi IOs? What are the
Okay,
sensors?
Peter. This one is testers. ADC Well, the first thing I think of is ADC because the GPIO on the Raspberry Pi doesn't have ADC input.
Mm,
Oh,
mm,
the first thing I can. Then the 5 volt, no, anything that is 5 volt logic, don't connect directly to Pi because
mm,
Pi is actually the IO is 3.3 volt Of course, there is 5 volt pin on Pi, but that is actually a power pin. Oh,
mm.
so don't mistakenly pump in
Yeah.
one, then your Pi smoke come out.
Yeah, so if your project need to use ADC, it's best go to controllers.
Yep,
Controllers, more varieties also.
yep.
And then, but I think these days we have 5 volt IoT microcontrollers also, not just 3.3 volts anymore, right? It's quite, I think got 5 volt.
Can. Got is not common only. For example, if you use Arduino Uno plus with let's say Wi-Fi shield then you get
Mm-hmm.
you can still do Wi-Fi IoT stuff. Then the I/O is still 5 volt.
Yeah. Okay.
Like making a
Yeah.
small robot car.
Okay. So guys, do you still have more questions? Right. Can still drop. We are gonna stay 1 more minute before we end our session. Right. Mr.
Yeah,
Ober
yeah.
is here, so drop your questions.
Sorry, guys. Sorry, guys.
It's
I
okay.
need to apologize.
Oh, come on. I found one question here. This is important.
Okay. Is Raspberry Pi open source like Arduino? Anyone can modify the board. You can modify the board actually. It's at your own risk. You can always modify whatever board you have, but it's at your own risk lah. Is Raspberry Pi open source? The schematic is open, but I think the kernel or the software is also open, but you cannot. There is no what we call uh, Raspberry Pi compatible board outside there. It's not like Arduino. One of the reason is the processor. We are talking about the processor. Actually, processor is which one? This one. Maybe Adrian didn't show, right? Processor is actually this
Not
one.
yet.
This is actually a quite old Raspberry Pi. This is 3B. This one. This one is a processor. So if you compare to Arduino, I have a original Arduino over here. This is the microcontroller. Where is it? This one. Sorry. This one.
Mm-hmm.
Is a microcontroller.
Classic.
The problem with Raspberry Pi, not the problem actually. There's no clone. I want to highlight. There's no clone Raspberry Pi. Sometimes people ask, "Hey, I have a Raspberry Pi. I want to buy clone one. Have or compatible. They call it compatible. There's no compatible Raspberry Pi. There is only computer. Computer. For example, Banana Pi, Orange Pi. Those kind of board. Yes. One of the reason is the processor is from Broadcom. Okay, and for this model, Broadcom only offer to Raspberry Pi Foundation. So those model that on Raspberry Pi, for example, 3B, 3B Plus, they have different kind of processor, and 4B. Then 4B is have a lot of variation in the latest one. So that model of processor, Broadcom offer to Raspberry Pi on it. So that's why if you want to use Raspberry Pi, it's not only the board, but also the whole ecosystem, right? The Raspberry Pi OS, the other OS, compatible OS that support Raspberry Pi board. So the whole ecosystem is actually Raspberry Pi. So it's very difficult to have to build up the whole
Clone,
ecosystem.
yeah.
Yeah. So
Yeah.
hopefully I answer that lah.
Yes.
If you're talking about you want to modify, go ahead. The schematic is actually there outside there someplace lah.
Yeah.
It's open. So for example, they want to check this pin connect to this pin. There is some people, take off the IC. For example, the USB hub, take off. They connect their own IC here. some gig lah, maker gigs
This one is
they
hacking already.
remove.
Yeah. You're hacking already.
Hack it. So they actually have the schematic in some place. I don't know lah. Okay. So
Yeah.
hopefully I answer that question.
Yeah. Basically everything
last
can be
one.
hacked. Yeah.
Yeah.
Come.
Last one.
Okay. Last question.
IP table. Which one? This one. This one. Can you give advice? So
Oh,
I'm not sure. IP table. So
okay.
networking idea.
Yeah, but feel free to join our Telegram and then you can
Yeah.
ask us more on this.
Not only us, because inside the Telegram, there's a
Yes.
lot of sifu there, a lot of guru there.
Okay, come.
Any recommended way of communicating between microcontroller and Pi? Oh, microcontroller. If you have USB, that's the best way. For example, Arduino. There is Arduino. Just plug to the USB. Then you can use as a computer. So Raspberry Pi can take data, can send command to the Arduino. Then the Arduino can have a small program to do whatever you want it to do lah. Then Raspberry Pi can be a data collector, processor, process all the data between all the other Arduino. So you can do that also. Okay.
Yes.
Yep. Yep.
Okay. All right. Thanks for all the questions, guys. Thanks for all the questions. So we hope you find our today's session valuable. We are gonna end our session right now. But if you are interested to purchase something this weekend, feel free to check out the Cytron's website. We have this voucher going on. If you look at the bottom bar in our streaming right now,
Okay.
get a free Trust Me baseball cap, which is what Obo is wearing right now. If you spend minimum order of 50 ringgit, here's the voucher code. Yeah, you're wearing the baseball cap.
Yeah, baseball cap. This one, this one.
Get a free baseball cap.
My camera is from my keyboard, so. One of the question, Shaman. I
Yes,
thought
come,
original
come.
Arduino are green in color. Actually, no.
Mm,
Long time they changed to blue already. Okay, it's actually blue in color. This original Uno.
I thought the original is like bluish green,
Bluish.
bluish green kind. Yeah, and then
Uh,
the clone one is more blue.
yeah, they try to follow. So the green is this one. This is a Raspberry Pi. Raspberry Pi is always green. Raspberry Pi. Oh, and this is old Raspberry Pi. I have a version 1 Raspberry Pi here. This is version 1 Raspberry Pi. Okay. Raspberry Pi is always green. There is one version which is blue, but it's not available in our region. This is 0.
Before I end up, another question. So because microcontroller is so popular, right? Raspberry Pi is also moving into microcontrollers, right?
Ah,
They
they
it's
come out with Pico.
so Pico, is it like a good comparison with Arduino? Is Pico like a good comparison? Maybe we can have another session on that.
Maybe
Arduino
that's
versus
a
Pico.
very good topic. Yep. That would be a very good topic. For example, Pico, Raspberry Pi Pico versus Arduino. But it's kind of complex because now you cannot say Raspberry Pi is a computer anymore because they come out with a microcontroller. Then if
Yeah.
you want to compare Pico versus Arduino, it must be a board specific because Arduino also use the microcontroller on Pico to come up with their own board.
They
So
need the
need to be
model, right? The model,
we
the
need to
specific
specific
model.
the model
Mm.
specify the model. Yeah. A very good
Okay.
topic. Very good topic. Yeah.
Okay. All right. Okay. Thanks. Okay. I
Thanks,
think
guys.
we are gonna end here. So do catch us on our next Wednesday webinar. And thank you guys for joining us today. Thank you. Thanks, Ober, for
Hey,
joining
no problem.
in.
Sorry for being
Hey,
late.
thank you. It's okay. It's okay. Thanks. Thanks for coming. All right.
Okay.
Thank you guys. See you again.